let's take a look at section 4.1. 4.1 is going to seem like it's coming out of nowhere, but it's going to get used a lot on test 3 when we're dealing with something called factoring. So this will lead into chapter 5 for test 3. But right now for test 2, it's going to seem like it's kind of off on its own and its own idea, and that's okay. So let's take a look at exponents. When we have exponents, we usually have something that we have that's called a base, and then it's raised to something small called an exponent, or you might also call it a power. So a power, exponent, however you want to say it, it all means the same thing. Now your base could be a letter like X, like it is in this first example. That's your base is X. Or it could be a number. So we've got a base and an exponent or power. And what the power tells us is how many times to multiply the base by itself. So when we have this first one, the x to the 6, it's telling us to multiply the base x by itself 6 times. So 1, 2, 3, 4, 5, 6 copies of x is what it means, is that it should be multiplied by itself 6 times. So in this example, like I said, is the base is x and the exponent or power is 6. So we have to be very careful with exponents because how they write things out can make a completely different answer. For example, on this next one, we have a -2 inside of parentheses raised to the 4th power. That means that the -2 is going to get multiplied by itself 4 times. So you'd work this out like you would normally, and you'd start out with -2 times -2, which is 4. And then you would say, okay, well, now take that 4 times another -2, which is -8, times that last -2. We'll turn this back into a positive 16. Now notice we are multiplying the -2 by itself 4 times. Those parentheses make sure that you know that what's getting multiplied by itself 4 times is the entire number -2 because it's held together by those parentheses. However, if you look at B here, or the next one, you don't see any parentheses, which means that your exponent is only on the 2. So the thing that you're multiplying by itself 4 times is only the 2. So we have a 2 times 2 times 2. And that negative sign that's out in front is just going to go on as a part of our final answer at the end. So I need to do, according to the order of operations, all of this multiplication first. The 2 times 2 times 2 times 2. Well, 2 times 2 is 4, times another 2 is 8, times another 2 is 16. However, we said that this negative sign that was sitting out in front that has nothing to do with our exponent gets tacked on at the end. So I actually end up with a -16. So be careful. These two answers are not the same, and that's because one had parentheses and one didn't. So we do have to be very careful. So in this section, we're going to see a lot of rules for exponents. A good way to kind of explain them, though, is to kind of see an example. So that's what I'll do here is we've got x to the 3rd as an example times x squared. So this is going to be what's considered a product rule for exponents. Why? Because we are multiplying. Multiplying means that you're taking a product. Well, if you're multiplying two things like this, your bases have to stay the same, which they are. We have an x and an x. So as long as the bases match, you can multiply. And what this rule says is that the base will stay the same, will stay as an x. And what will happen is you will just go ahead and add the exponents. So because the exponents are a 3 and a 2, you'll add them up and you'll get a total of 5. So the way that I think about this is saying, well, I've got 3 x's and 2 more for a total of 5 x's. But again, the key is the base stays the same. The x is the base, and that's not going to change. Only the exponents are changing. If you ever get stuck, though, you can always kind of think of this long-handed. X to the third is x times x times x. And x squared is x times x. And we said we were multiplying these. So I can put them all back together and say, well, how many x's are multiplied together here? That's a total of 5, and that's why you get x to the 5th. Your x's aren't changing. They're still only just x's, but now I have 5 of them. So the base stays the same, and you just add exponents if you're multiplying. If the bases don't match, you can't combine them because it's like apples and oranges. They're completely different. So let's take a look at a couple examples. On the first example, we have x to the 5th times x to the 4th. The bases do match, which is all we need. And so we have a base of x, so that will stay the same. And then we have our exponents, which are 5 and 4. We are multiplying. Well, if you're multiplying, what do you do to your exponents? You add them up and say, well, I've got 5 x's and 4 x's, which give me a total of 9 x's. And that's my final answer. Let's try another one. Let's look at B. In B, we have x to the 3rd times x to the 4th times x. Again, it doesn't matter that there are 3 terms here. It's just that they all have a base of x. So an x times an x times an x means we're still going to have x's. Remember, the base will stay the same. It will stay as an x. Well, let's count up all our x's. Well, we've got 3 x's. Plus 4 more, so we've got 7, and we don't see a number there, but remember there's always a hidden 1, so I have 3 plus 4 is 7, plus 1 more is 8. So I've got 3 x's, then 4 more, 7, plus 1 more is 8, and that's my final answer. Let's take a look at C now. In C, notice we have parentheses here. And whenever you see parentheses, that means that they want me to go after that part first. So I need to start with what's inside of the parentheses first. That's always how we do things since we've learned order of operations. So we've got our x and our x here. Remember, the base will stay the same, so that will stay as an x. So, but I have an x to the 4th, and I can't see it on the second piece, but I've got an x to the 1st. I've got 1 x there. So 4 and 1 more is a total of 5. Be careful not to forget there was an x to the 5th outside too that I can't forget. So now they're just side by side because I've dealt with what was inside of the parentheses. So again, let's continue. We still have x's. We have an x and an x. Remember, the base will stay the same, so it will stay as an x again. But now I've got 5 x's here and 5 x's here, so when I add them up, because I'm multiplying, I get a total of 5, and 5 is a total of 10 x's. So my final answer is this x to the 10th. Notice, we may get some really large exponents for our answers, and so it's going to be really hard for us to trust our answers because they're going to look funny because we really haven't seen exponents this large ever. Let's take a look at one more. Let's take a look at D. We've got negative 3x cubed times negative 4x to the 4th. And let's see what happens. Well, notice we do have just 2 normal numbers multiplied together. We have a negative 3 times a negative 4. Those are just normal numbers. They don't have any exponents. So we can just multiply those normally. So if I gave you the problem and said, what's negative 3 times negative 4? You would just say, without hesitation, a positive 12. Now, our new part is how to multiply these x cubed, and x to the fourth. That's the only new part. Well, notice the bases match. An x and an x means the base will stay the same with just another x. And you do what to the exponents? Remember, we add them if we're multiplying. We count them up. So we have 3 here and 4 here for a total of 7. And that's it. Our final answer is 12x to the 7th. Let's try one last one here. We've got a negative 2x times a negative x cubed times a negative 3x. So let's kind of break this up into parts. Let's deal with our normal numbers first, like we just did on the last one, and see what happens. So we have a negative 2 times a negative times a negative 3. Let's see what happens here. So the negative 2 times a negative will become a positive 2 times a negative 3, though, will turn back into a negative 6. So that's one part of this dealt with and not too big of a deal. Now I need to multiply my x's. I've got an x cubed, and an x. So remember, if I'm multiplying, I'm adding up how many x's I have. If I don't see an exponent, it's a hidden 1. So let's count these up. So I've got 1 plus 3 more is 4, plus 1 more is a total of 5. 5 what's? Well, these were all x's. So I'm going to have 5 x's when I combine all these x's and add them all up because I'm multiplying. So I'm going to have an x to the 5th power. And that's my final answer, is negative 6x to the 5th. In this next problem,